welcome to Clean Coder YouTube channel. If you are new to this channel, I'll highly recommend you to subscribe to my channel as I make content related to software engineering, system design, and data structures and algorithms. So this is a really important principle of object-oriented programming. So let's try to go towards depth of this topic. So let's say that the record shop we discussed also sells Blu-ray movies. Okay, this is a type of a movie, right? So what we can do is, as you can see in the above diagram, there are many common states and behaviors between album and movie. When implementing this class diagram into code, are you going to write or copy and paste the entire code for a movie? If you can do, you are repeating yourself, right? How can you avoid code duplication? This is where we use inheritance. Okay. So remember, whenever you are coding, whenever you are duplicating a lot of variables, you are duplicating a lot of things, inheritance could be used, and this is a kind of good code smell that you may be violating the OOPS principle by not using inheritance where inheritance should be used. So let's go more in depth of this topic. Let's scroll down a bit. Okay, so inheritance is a mechanism in which one object acquires all the states and behaviors of a parent object. Okay, inheritance uses parent-child relationship or is a relationship. So what exactly is inherited? Okay, let's read this. Visibility, access, modifier, impact. What gets inherited from one class to another? In Java, as a rule of thumb, we make instance variables private, okay, and instant methods public. In this case, we can safely say that the following are inherited. Okay, we only inherit public instance methods. Okay, in this case, if instance variables are private and only public getter setter are exposed. So private instance variables can be accessed only through public getter and setter, which we have exposed. Okay, so now let's scroll down a bit. Okay, so these are the type of inheritance in Java. So there are almost 5 types of inheritance in Java. They are single, multi-level, hierarchical, multiple, and hybrid. So classes, remember, this is a very good interview question. So classes allows single and multi-level and hierarchical inheritance only. And only interfaces allow multiple and hybrid. Okay, there is difference between multiple and multi-level, remember. This is because like in Java you can only do something like class A extends, okay, B. You can't do something like class A extends B comma C comma D. This kind of thing is not allowed with extend keyword. Okay, remember this. You can only extend a single class. That's why it's multi-level. Okay, but not multiple in case of class. But in case of interface, you can happily do like class A implements multiple interfaces. Okay, interface, let's say B, C, D, so on and so forth. This is permissible, this is valid. Okay, but this is not valid. So in the first diagram, he has shown us is the example of single inheritance. Okay, so class B is inheriting from class A. This is single inheritance and class supports this. Similarly, in second example, he has given us multi-level inheritance, right? So again, this is supported by class, but hierarchical, okay, hierarchical is also supported because see here, like class B is only inheriting one class, which is class A. Similarly, class C is inheriting only one class, which is class A. So this is also fine in case of class. But the next inheritances which he has shown, those are not allowed in Java. Okay, so let's try to read them. So multiple inheritance, this is not allowed. Okay, and hybrid, this part is not allowed. So these things you can achieve using interfaces, but not using class or inheritance or extents. Okay, remember in C++, multiple inheritance is allowed, but in Java, multiple inheritance is not allowed. Okay, so you need to pay special attention to this fact. Okay, so now let's scroll down a bit. So let's read this theory. A class can extend only one class, or it can implement any number of interfaces, and an interface can extend more than one interfaces. So he's captured this in tabular form. So when a parent is a class and a child is class, the keyword which you are going to use is extends. Similarly, when a parent is an interface and child is an interface, again you can use extends. And when a parent is interface but child is a class, you're going to use implements. Okay, so this is what he's trying to say. So the next part which we are going to cover in this tutorial is in relationships. Okay, there are actually different kinds of relationships. So is a relationship is what we generally study in inheritance. Okay, is a relationship is what we study in inheritance. So this is commonly achieved using extends keyword. Okay, extends slash implements. Okay, so these two keywords are used to achieve is a relationship. But like generalization is a another kind of relationship. So generalization uses an is a relationship and from a specialization class to generalization class. Okay, so this is the generalization concept. Okay, so this is special feature, then general feature. This is example of generalization. Okay, then there is a as a relationship. Okay, so what is a has a relationship? So has a relationship is when an instance of one class has a reference to an instance of another class. So this becomes has a relationship. Okay, so aggregation uses has a relationship. Here you can see like in this relationship the existence of class A and class B are not dependent on each other. Okay, for this aggregation part we are going to see an example of the student class and the contact information class. Okay, okay, so this is a contact information class and this is student class, and you can clearly see student has contact info and has a relationship is maintained here. Okay, so this is what is meant by has a relationship. Like this is trivial stuff you can study on your own. Next part which we are going to study is composition. So composition also uses has a relationship, and in this relationship class B cannot exist without class A, but class A can exist without class B. To give you an idea about composition, let's see an example of student class and student ID class. Okay, so student has a student ID, right? This is like composition as a relationship. Now let's get back to our previous record shop example that we discussed above. Okay, so this example you can go through on your own, but like the gist is we can implement this diagram in Java to avoid code duplication, like we are using inheritance. Okay, so next part which we are going to study is advantages of inheritance. So what all are advantages of inheritance. Okay, so the first thing is code reuse. So the child class inherit all instance members of the parent class. So we are saving the code duplication. We are reusing already the implementations we have in the parent class, or we can provide the overrides if we need. So code reuse is happening. This is the best part of inheritance. And the second part is we have more flexibility to change code. Okay, we are decoupling our system. Changing code in place is enough. Okay, this what. And the third part is we can use polymorphism. Okay, so in polymorphism principle, we are going to study how with inheritance we can use polymorphism, especially the like runtime polymorphism, or like method overriding polymorphism. Okay, this requires is a relationship. For this we are going to study later. Hey guys, do check out this Instagram channel, Clean Coder Community, for all the jokes and memes related to software engineering. Thanks a lot.